Hello and welcome to Channel 9 Live, direct from the future. Because we are 20 hours ahead of Pacific time if you're watching in the United States. We are in New Zealand and I'm very excited to be here for Microsoft Ignite NZ. Because you got to say it right.
That's right.
That's right. And I've got a very special guest with us, fresh off of the keynote stage. Why don't you present yourself? Tell us who you are and what you do.
Hello, my name is Jennifer Marsman, and I was presenting today about machine learning. So yes, something that Seth is familiar with as well.
I am not as familiar maybe as her, and so we are going to seriously talk a little bit about what you talked about and get into a couple of topics. If you want to ask questions, feel free to ask them on channel9.msdn.com. You'll be able to ask them in the box below, and I can see them right here, and so we'll ask them. Have your questions come in, and we will answer them. So let's start first with, tell us about your keynote.
Yes, so what I talked about today is some research I've been doing around machine learning. So I have a headset that was made by a company called Emotive, which is a female-founded company, woohoo! And yes. And so what I did was I took this headset and I put it on my husband and I asked him a bunch of questions. And first I had him tell me the truth, and then I asked him to lie to me. And what that gave me was a labeled data set of what his brainwaves looked like when he was telling the truth and what it looked like when he was lying. So then I took that data, fed it into Azure Machine Learning, and built a classifier to perform lie detection. So that's what I talked about, yes.
So let's get into the nitty-gritty of this, because I've always been curious, because I'm wondering, what does the data look like? Is it just a set of numbers, rows of numbers?
Yeah, great question. So what the data looks like, so it actually reads EEG data from 14 different positions in the brain, so you can kind of isolate different areas. And it's numbers, so it's numerical data measuring the EEG signal, and then we have the actual numbers, so the actual values that we're reading, which are numbers that are typically in the 4,000s.
Sure.
And then there are also a measure of signal strength. So the model I'm using is the Emotive Epoch Plus, and that it uses a wet sensor. So there's little felt pads that you have to screw on the device before you put it on, and I have to wet them with saline solution, the same thing I use for my contact lenses. Yeah, you put on there, and so that moisture allows it to get a good signal contact. Yeah. And so it actually measures for each one of those 14 nodes on your head, it measures the signal strength as well. So you can use that to do some data cleaning. It's actually an enumeration of 5, I think, is the perfect signal strength, or I'm sorry, 4 is the perfect signal strength. And then there's actually, it's from 0 to 4, 5 different levels of signal degradation.
So each number you get from each of the 14 signals is a number around the range of 4,000.
Yep.
And then between 0 and 4 that says this is how confident we are in that number.
Right, and you get that for each of the 14 nodes. So you get a signal quality on each of those, because sometimes I have like a chunk of hair in the way or that sort of thing where it's not reading well from one of them, or one of them's not wet enough or something like that.
And so whenever you're actually, because the way I understand machine learning is we have a row of data and then a label that says liar or not.
Right.
But you're probably getting a bunch of values when they're maybe lying or when they're not. How do you compress those into a particular row?
Yeah, great question. So what I did was, first of all, I had this data, I was asking questions, and I asked a series of questions and actually repeated the questions a couple times so that I could take averages, just because EEG data is notoriously messy, noisy data.
Right.
You can get like facial movements, it will pick up facial movements and things like that. So there is a lot of things to keep in mind. So then, when I was actually asking the questions, I started by, well, this is kind of a couple things in, but I actually put a marker in the data for when I started to ask the question, and then another marker in the data for when he finished answering. So that allowed me to extract out just the relevant parts where his mind was actually thinking about the answer in order to make the best decision.
And did you aggregate it to like the average, and that would be your row?
Yeah, so I did a couple different things. I've explored a whole lot of different ways to work with this data. One way is to just start simple and do things like the min wave, max wave, standard deviation, things like that. So that's kind of one thing I tried that. I've also done some work with basically unrolling the waveform. So imagine you have this brain wave, and so you can actually take all 14 values at any given time and expand those out in a row and use that. And that works well if you can isolate and make sure they're all starting at the same time. That'll work. But if you have trouble with that, that can be hard. There's also a Pi EEG library out there that I found online, so I tried that. There's also some time frequency band filtering. So if you're familiar with like some digital signal processing, it's some of that kind of thing to be able to get interesting stuff there. And then the other thing, and this I haven't done yet because I don't have quite enough data yet, but what I really want to experiment more with is deep learning. Now, when you think about it, the problem of detecting lies from an EEG is very similar to something like speech recognition, right? Because our brain waves are all, each brain has a unique signature, much like our voices when we talk. And of course, you guys have all seen an audio file and know that, our voices have audio thing, which is much like a brainwave, signal. And so it's a very, very similar problem. So you can do some normalization like we do in speech recognition to be able to make it work for everyone. And so that's kind of what I'm thinking about. The problem, the reason I haven't done deep learning yet, because, and of course, deep learning has actually solved the problem of speech recognition. If you use deep learning techniques, that's actually a solved problem at this point. So I think I could use those techniques pretty effectively here. My issue is I just don't have enough data yet. I'm collecting data from people in my spare time and that sort of thing. So it's just a matter of getting enough data to make it effective.
Awesome. Well, as we're listening, please make sure to ask questions so that we can get these answered. We have an expert here on machine learning to help us out. So once you have this data, tell me, because you want to do the deep learning stuff, how do you know how much data you need? Because you mentioned I don't have enough. How do you know that, and how do you know when you have enough?
Yeah. So right now I've gathered data. So so the way supervised machine learning works, to take a step back, the way supervised machine learning works is you have something that you want to predict, right? And we typically call that our label. And then we also have a whole bunch of things that affect influencing factors that affect that thing that we're trying to predict, right? So take the example of trying to predict the cost of a home. You may have a whole bunch of features, things like the number of bedrooms, number of bathrooms, square footage, location, number of years since the master bathroom has been remodeled, whatever. So those kind of things, and then you would have a label that's here's the actual price of the home. And so to make it effective, you actually have to have enough data to significantly cover kind of all the use cases. So if I wanted to predict housing prices in Seattle and Detroit and Silicon Valley, for example, I would want some data from all of those locations to train it to make it more effective. And that may not accurately predict the price of a home in Texas, for example. So you have to kind of have enough to cover the scenarios that you want. So that's what I'm thinking. And currently I have data from, I think, about 25 different users. And I think I've asked them, I'm trying to remember how many questions, like 14 times 3 questions each. With repetitive, so yeah, I think it's not quite enough yet.
Yeah, and it feels like 25 people may not be representative of
the entire population. Exactly. So I actually, every person that I've worked with, I've had them sign something just saying, hey, I might release this data to the public at some point, and are you okay with that? And they've all willingly said yes. You know what, this is really cool. Sure, you can use my brain data. And so I've taken that data and I have that list of these folks, and I've tried to find a variety of folks who, across genders, I've tried to grab an equal number of male and female data. I also have been experimenting, I've been noting if they were right-handed or left-handed, just in case. You know how it sometimes says that there's a correlation between the dominant side of the brain and what hand, and I don't know if that's true or not, but we can find out. We can at least have the data. It's never bad to have too much data. So.
And not only that, but I mean, my sense is that people just think differently all the way around.
Absolutely.
And so if you're only in the United States, you might only get a certain way of thinking. If you're in France, you might get a certain way of thinking.
Absolutely. Absolutely.
So how do you know, here's a question. Someone might be like, I want to do some machine learning. How will they know that they have a representative enough data set in order to make their machine learning algorithms work?
Yeah, so I think it depends on the problem you want to solve at the end of the day.
Sure.
So if I was, a police organization in the United States, and so I'm only working in the jurisdiction of, the United States, for example, then maybe training the data with just people from the United States is enough.
Sure.
But it really depends on the problem that you want to solve and how you want to use that data. And as we know, garbage in, garbage out.
Right.
So you have to always think about, it's really important in machine learning to think about the quality of that data that you're getting, and was there any, implicit bias or things like that in that data, because it's just going to train based on what it learns, right?
So this is awesome stuff. So we talked about sort of the nitty-gritty of machine learning. Let's level up and talk a little bit about how Azure sort of helped you make this model work.
Yes, so Azure, I did use Azure Machine Learning, which is a phenomenal tool. It's very powerful. If you're a developer and you don't have much of a machine learning background, there's a lot of great resources, like the Azure Machine Learning cheat sheet to help you get up to speed and kind of learn some of this stuff as you're going. And then there's also, if you are, a data scientist or have a strong machine learning background, it's great because there are things, it can act as like a rapid application development tool almost, where you have these 25 different algorithms, so you can swap algorithms in and out fairly easily and try different things in a quick, effective way.
And the cool thing is that, I saw it early on, like years ago.
Yep.
It's getting so much better.
It is. The team has been making improvements. They're listening and taking feedback. There's a great Connect site where you can, make your feature requests and stuff, and the team is actively monitoring that and trying to make trying to build a better and better product. So
for someone that's using Azure ML, what are some tips that you have for them other than the sort of the stuff you've already mentioned? Like if they have a problem, how can they think about that problem and then use their Azure ML?
Yeah, so I would just break it down first and figure out what kind of problem are you trying to solve. If you're trying to make a prediction, like I mentioned, then that's a supervised machine learning problem, and Azure Machine Learning has support for regression and classification and anomaly detection, which are 3 different kinds of supervised machine learning. So regression and classification, the difference between those two are classification enables you to predict something between several buckets. So is my husband lying or telling the truth?
Right.
Those 2 distinct buckets. Will this person, which sports team is going to win, Michigan or Michigan State? Something like that. So it's determining between buckets. Now regression, what that is trying to do is predict a value on a continuum. So a number, essentially. So think about things like the example of predicting the price of a home.
Right.
I might have examples that are several different prices, and maybe I have examples that are 20, this house is going to cost 20 grand, 30 grand, 40 grand, but it could still predict new numbers by extrapolating or in between those values.
Absolutely.
And being able to do that. And then anomaly detection is a fun one. So anomaly detection is really useful when you have this scenario of a highly unbalanced data set. So take the example of credit card fraud detection, right? You're going to have data where I have a whole lot of valid transactions, and then I have a very, very small amount of fraudulent transactions, and then the known fraudulent transactions are going to be even smaller than that.
Right.
Excuse me as I work interpretive dance, a Venn diagram here, right?
Hands here. Jazz hands on machine
right?
learning.
I like to make Venn diagrams with my hands. But you can see that would be a highly unbalanced data set, and so typical classification algorithms don't work very well when you are dealing with a unbalanced data set like that. So you can use anomaly detection, and basically that will help account for that.
What a good way of looking at that. Typically that's called unsupervised learning from what I understand.
So unsupervised learning, you don't need a labeled data set. So unsupervised learning encompasses things like clustering, for example, is unsupervised learning. And then there's reinforcement learning as well, which is like turn-based things like the chess and the AlphaGo, or Go, the game of Go and such.
And so does Azure ML help you with all of those kinds of things or a certain subset?
Yes, so Azure Machine Learning currently today helps with supervised learning and unsupervised learning. So for unsupervised learning, we have a k-means clustering algorithm, which is the one that's typically used industry standard.
Sure.
And then we have a number of supervised machine learning algorithms.
Awesome. So let's level up even more because it feels like Azure ML is like you're down. We went all the way down the weeds with the data set. Now we went into sort of how you can sort of make these work. But then there's certain machine learning problems that are just like, we've done them so many times. Does Azure sort of offer a way for us to solve those too?
Absolutely. So that's where I would really look to cognitive services.
Okay.
So the cognitive services are really amazing in that they took what were in the past kind of really hard, challenging artificial intelligence problems, but at this point are basically solved problems. So things like facial detection, being able to recognize the bounding box of my face, and emotion classification, so figuring out what emotion am I expressing, and just things like that. And it's able to take pre-trained models. So Microsoft Research has taken the algorithms that they've developed over the years, and a lot of these are published in papers that you can go and read and understand kind of what's going on under the covers.
Sure.
So you can take then those learnings, and then they've exposed those models to you to use. So if I want to do facial detection, it's as easy as making a REST call where I send it a picture, and then I get back, here's the facial bounding boxes, and here's the age of the person, and here's their gender, and here's all these other 27 different, there's actually 27 different facial points that are of interest, and it will give you all of those. So lots of really neat stuff.
That's amazing because now it feels like like just the order of things, right? We talked about sort of data, and you want to have your own special thing. We talked about Azure ML, sort of abstracts away the knowledge of having to know about the algorithms. And now we're talking about cognitive services, how they help you sort of do more complex tasks. You mentioned facial recognition. What other tasks can it solve?
Great question. So cognitive services has facial detection as well as other things with the face. There's other facial APIs as well for grouping similar faces together if you wanted to say, like, what celebrity do I look most like, or things like that. And then just find all the pictures of me in this particular group of photos. There's all kinds of things like that. In addition, there's some video processing algorithms as well. So you can use video to understand, you can do some motion stabilization, it can pick out faces, things like that. And then in the kind of the knowledge space, there's some interesting knowledge graph stuff that's available. So you can dive into and explore that. There's a recommendations engine that is really powerful. A lot of people are using that right now for your online channels, being able to do things like, you know, if I'm buying X, they might also want to buy Y, or, you know, frequently bought together and those types of things. We also have text analytics, so I've done some fun stuff with that. They have sentiment analysis in there, and being able to extract kind of the key topics, which is nice. Imagine like all of your help logs and being able to extract what are the key things that people are asking about. Really, really good stuff there. And then there's also LUIS, the Language Understanding Intelligence Service, and that's really great for things like building bots and being able to parse natural language. LUIS allows you to basically specify a number of intents and then be able to ask something in natural language, and it creates a lot of natural language to intent mappings, and then it will kind of return, here's the intent that I think that best maps to.
So we have about 10 more minutes, and so I really want to dive into this last topic, because I think Lewis sort of helps us dive into it, and we'll get into more of that. But let's talk about the topic of bots. It's something that everyone all of a sudden has been wanting to do. You know, we did it, Facebook did it, other people are doing it. What is it about bots that you think is important for people to know?
So what I think is important is we spend so much time on chat interfaces. So I know it seems very simple to have kind of these text-based back and forths, but when you think about it, the amount of time I spend on Slack or on Facebook Messenger or those kinds of things, it can actually be really useful. And those are just kind of like consumery scenarios. When you think about things like an enterprise that has to manage their support and call center, that's actually a really, really challenging problem. And to be able to do something like automate some of those simple questions, so I ask a question and then hear back, you know, here's how we can continue with this conversation and be able to solve some of those simple problems just using an automated bot, and then direct harder problems to a human, you're already kind of saving some time and money.
So I've seen some of the bots, and this is going to sound kind of harsh, but hopefully you can help me because maybe I just don't know. Like most of the bots that I've seen have degraded into this sort of command line experience, which you can get using CMD. Are people doing it right? Is there a better way? What do you say?
So so first of all, I think we need to publish some best practices around building bots and kind of architecture and what scenarios do bot make sense, because you don't want to throw a bot at anything. It doesn't make sense to always do. But there's like two scenarios that I think are really, really compelling. One is the scenario of just wanting to answer some basic questions. So it's a more open-ended thing, like I want to be able to book a flight or cancel my flight or check in for my flight. And so we have this flight bot where I can issue natural language things like I want to book a flight. And the bot framework does allow you to store off some state. So it could, you know, if I've interacted with it before and it asked, you know, where is your home airport, it could remember that information about me. So then if in a later session I ask it, I want to fly to Paris on this day, it can say, okay, looking for things from your home city to Paris directly by kind of managing some of that for you. So that's a really kind of interesting thing right there. The other thing to think about too is just how much we use bots in things like Siri and Cortana and Alexa and OK Google, which really needs a fun, you know, women's name. But do you see what I'm saying? Like there's just, I use that all the time. Do you use it, Seth?
I use it sometimes. I mean, I'm old school though. I feel like I'm old.
Okay, so I'm a huge, like I love having a personal assistant.
My wife uses it all the time.
Okay, so maybe, I don't know. But I use Cortana all the time. So I have a Windows phone and I use Cortana and I'm constantly saying, oh, remind me to do this when I get home, or oh my gosh, I remembered something that I need to do for the kids or whatever. So I'm constantly like giving myself reminders, and it can, you know, use location based and other things. And so I really see that, just the idea of a personal assistant. I mean, that was that was kind of the end goal of artificial intelligence at the beginning, right? At the whole beginning of this game, it's can we have something that can help us, that can help humanity, right? And so having kind of this interface of a bot that can help you and make your life easier is kind of a neat thing, both in the consumer space and the enterprise space.
So you mentioned sort of best practices.
Yes.
Can you give us some guidelines of like, here's some thou shalts and thou shalt not with bots? And by the way, if you have questions, please submit them. We want to hear them. I'd love to hear sort of your analysis of what you should do with a bot and what you should literally just stay away from.
Okay, so first of all, you shouldn't use a bot for just anything. So a bot is an application, but there are some cases where it makes sense and some cases where it doesn't. I had mentioned that first scenario. I don't think I ever said the second scenario. I mentioned the first scenario of just being able to ask simple questions and get a response back, like booking a flight and getting it back. The second scenario is the idea of a guided wizard. So having a bot that can actually walk you through a process, right? So that's a great thing when it's like, okay, I need to, go through this pre-flight checklist for an airport, or I need to order a sandwich, and there's just very certain steps that you follow in order to make those things happen.
Of course.
And so in that case, you can figure out, okay, does it make sense to do this? And if it's something that you're doing like through text commands anyway, I think a lot of times that does make sense to maybe use a bot. And then you can think about using voice on top of the text as well to add another dimension. And there are folks who are doing that today as well.
I see. So you would use cognitive services to translate audio text into written text, send that off to a bot to do.
That's one way to do it. And then the other thing is that, one of the other best practices we found with people building bots, Lewis is a really, really compelling scenario. So again, what Lewis allows you to do is map these natural language utterances to intents, and then you can send it by making a couple examples. So let's use the example of booking a flight. So booking a flight is the intent, but there's several different natural language ways I could express that.
Sure.
I might say, book me a flight to Paris, or I want to fly from such and such to Paris, or there's a lot of different ways you could actually say that in natural language. So by putting in a couple of examples up front and then mapping those all to the book flight example, that allows it to figure out, okay, it looks like these things are related, and then it can kind of expand upon that. So that way, as you add new things and ask additional questions, you can get a decent response back.
So I'm trying to think of this API for Lewis.
The one other thing I want to say about that is that so Lewis is one thing that's very, very compelling for natural language to intent. But the other scenario that we've seen a lot is that sometimes you don't even need Lewis. Sometimes something like Azure Search is sufficient, where Azure Search allows you to just basically do keywords over a corpus of data.
Of course.
And sometimes just getting a response back of, okay, let me just grab the data that you're asking about and hand it back to you.
You're looking for this.
Is very simple, and that's an interesting scenario too. So we're seeing a lot of people using that. So Lewis and Search together.
So let's talk a little bit more about Lewis. When I'm going to Lewis, and you mentioned something about intents. If I give it a piece of text, is it just going to tell me this is what they want to do? What else does it tell me?
So it gives you back actually all of the possible intents with a confidence level on each one.
Oh, I see.
So the first one that's returned is the one that's the highest confidence. So if you want, you can just grab the first one that's returned because it's returned in order of the confidence. So you can use that one if you want and then say, okay, and then you might map that to some action. So in the case of, so I actually wrote a bot that I've been working on.
Got it.
And in this particular bot, the scenario was career fairs. Have you ever had to work a career fair where you go to a university and you're looking to hire people from Microsoft? So I've done that a lot. And so one of the things that's exciting about that is that there's all these students that want to talk to Microsoft, and I thought, wouldn't it be cool if there was a way to not only show them some of the cool stuff that we work on in Microsoft, but also answer some of the simple questions that you get asked repeated times. So I kind of put together, during our 1-week hackathon, I put together a really simple career bot that took maybe 15 different intents. So things like, what does the relocation package look like? And do I need a work visa? So work visas, location, the roles at Microsoft, benefits, things like that.
When I've heard of Lewis, I've heard of things called intents, like you mentioned, but I've also heard of this thing called entities. What are those things? So
entities are something that you might want to be able to parse out of your intent. So think about the example of I want to book a flight from New York to Paris. In that scenario, you need to know the source my source location and my destination. So I would, you could create a couple mappings and then say, okay, these are both examples of locations essentially, sure. And you need a source location and a destination location. And there's actually some neat hierarchical support within there for entities as well. So you can say, okay, these are locations, and here's an example of source and destination from there.
So they're giving me a sign to wrap it up. What do you want people to do today to get started to do these kinds of machine learning things?
Just think about how machine learning could help your business. There are so many options available. Everything from the cognitive services that have those pre-built models that you could just get started with super easy, like today, to building your own models to predict things that your own business has, using your own data, and then being able to predict things that, real problems that your business is facing. You could use Azure Machine Learning for that. And then there's the CNTK, which is our deep learning toolkit, and that's great when you want to kind of really go deep with stuff. So there's so many different things, so check them out and see which one makes sense for you.
Well, awesome, Jennifer. Thanks so much. Thanks so much for watching, and we will see you next time.